Yes, good morning, colleagues. It's very nice to see you all here on Monday morning. And today we're going to speak about Reaxys and how it will help us to improve the R&D productivity. So my colleague Alexei Moiseev will conduct the webinar, but please don't hesitate to ask questions during the seminar. Yeah, let's wait for a couple more minutes and then we'll start.
That will help you to get the information that you need. For example, you can write in the quick search tool your questions like preparation of methylphenidate and get the chemical reactions and documents about this. And very fast you can find some, and you can ask some information about some substance, like for example C10, and you can get the information in normalized, standardized, and collated information in one place. The more you're using Reaxys, the more easy you can get this information. You will understand where is the physical properties, where is the spectral properties, where is the bioactivity, where is the other information like stability on soil, abiotic degradation, and so on and so on. A lot oxygen demand, a lot of things you can get directly from our database. I will show you how it works. The most when you're going to the Reaxys, at first you will see quick search. Quick search is a very useful tool. You can ask your questions in the natural language, English language, and it will be transformed and translated to machine understandable format, and immediately you will get your information. For example, the most simple way, you can write here some name of the substance, for example, cetane. I placing here cetane, and what we can find about this substance in this database. We find information about cetane in different databases, in substances databases, in documents databases, in commercial substances databases, when you can get commercial availability of this substance. Let's click on database substances. You can find here a lot of substances, and of course you will find cetane. Yes, it's here. You can find all the document from where was extracted information about cetane from here. As you see, information about these substances appear in about 5,000 documents, like articles in journals, patents, information from books, from the conferences. And if we'll click to, let's click to documents, and we will see all the documents where we have information about this substance. We can analyze every document. We have a lot of information about every document, like which substances exist in this document. We extracted this information, which chemical reaction exists in this document. We also extracted this, and also we can get index terms. What author, field, index terms. Also what we extracted from our engineering database. What also we extracted for Reaxys for this document, and for some documents we have also the information from medical biological database Embase. The name is Embase, and you, without reading the document, you can understand what is inside of it. You don't need to read the document. You can understand what about this, because all these terms was extracted from the full text, and you can understand about what about this, and also uses substances and chemical reaction if they're existing. Also, what is very important, you can see citation in Scopus. You don't need to go to Scopus every time. Everything is here. And if we will click here to citate it 5 times, we will be redirected to Scopus directly, and you don't need to make any copy paste. You will be directly redirected to Scopus and see and analyze this document and work in Scopus. Sorry, my Scopus in Russian, but I think it's not a big problem for you, because we will focus on Reaxys today. Also, you can filter here by authors, by journals, by index terms. Index terms is the special chemical tools that not existing in Web of Science, not existing in Scopus. Why I think you will find it useful. If you will click on index terms and then to view more, you can start searching by this term by Reaxys taxonomy in this request. You can find, for example, information about chemical transformation and find some redox reaction, for example, or you can find physical chemical analytical method if you're interested in analytical chemistry, if you need to have chemical analysis, for example, thermal analysis if interesting, or thermal gravimetric analysis. You can limit to this, and in several seconds we filter it from 5,000 document to 100 document about thermogravimetric. It's very fast way to filter document by for the topic that you are really interested. Also, index terms, it's also could be interesting. It can give you additional filter that interesting for you. For example, you can find here viscosity. It's dynamic filter. It's filtering from this document index terms, and you can click on any terms and find what is really important for you. Also, you can find here, for example, information about patents. As I was telling you, we are really expanded dramatically last year our patent coverage. And what also we did, we also translated patent information to English language. I can show you. For example, we filtering by patent office, we filtering by Chinese patents. We find about 3 Chinese patents. What is interesting is that originally this document was published only in Chinese. If we will go to full text, we will be redirected to patent office's patent office website, and everything will be in Chinese. Without Reaxys, you're not able to find this document, you're not able to read this document, but with Reaxys we are translated manually or machinery to all the abstracts, all the claims, front pages, and also extract information, substances, and chemical reactions. And you can really find and read these documents, analyze them, and also in Reaxys you can use full text search by this document. Do you think it's helpful for you? Do you think it will help you in your everyday life? What do you think, colleagues? You can unmute yourself and give your comments, give your feedback, ask the question. Today, not so a lot of us. You can introduce yourself also, and might to be we can focus directly on your tasks and on your scientific topic, and try to find something that more interesting for you. Okay, let's continue. Let's go to back to our C10, to our substances. We can also find here information about chemical reaction where participate this substance. Just click to chemical reaction, and all the chemical reaction that was extracted from articles, patents, and other documents we will find here. What is important in Reaxys? Only one record for every chemical reaction and for every substances. There is no any duplication. It saves your time on analysis. Even if information was extracted from 3, 5, or 100 or 1,000 documents, it's not problem. It will be only one record. And if it was extracted from several documents, not a problem. You will find everything here. And you can find short conditions of the chemical reactions here, and also you can very often find experimental procedure that was extracted from full text from the full text of document. And in this case, you even don't need to go to full text to analyze everything. Everything is already extracted here. You don't need to spend your time on reading to find where it is in the document. Just take everything from Reaxys. You don't need to spend a lot of time. And what is also important, you can place here the mark and export everything to your hard drive in PDF or in Word on Excel file to plan your experimental work, to compare your experiment with others, and everything that we have from other scientists from over the world will be on your hard drive with links to original full text document. We don't have full text in Reaxys, but we have redirection to the full text on the publisher website. But very often you don't need really full text, because a lot of things you can get directly from Reaxys. You can find information about solvent, about the temperatures, about the pressures, about the chromatography analysis, about the chromatography purification, about absorption, and a lot of things that could be useful for you. And what is very important, you can compare chemical reactions from point of view of solvents, from point of view of temperatures, pressures, and other things, and choose the chemical reaction that really fits for you. And of course, compare from point of view of products, how many products we're getting, what the molecular weights, what the properties of impurities, what the toxicity of impurities, and you can optimize your process, optimize your synthesis process as you want. Also, what we have here, we can have a lot of filters. We have, for example, filter by yield, filter by reagent and catalysis. For example, filter by solvents, also very, very useful. You can choose, for example, water as a solvent and only find chemical reaction where used water as a solvent, or by solvent classes filter, or catalysis classes filter. For example, in solvent class filters, you can click on green solvent and only using green solvent in chemical reaction. It will be shown only chemical reaction where used green solvents like acetone. Sorry, it was a question.
لا انا مش عايزه اسال، انا فهمت انت فهمت غلط، لا انا مش عايزه اسال.
Dr. Heiji, it was a question.
Yes, can you repeat, please? We didn't get you. I think, Alexei, you can continue, and in case of questions, and if you are struggling to ask it, so please don't hesitate to write it in the chat room. Thank you.
Okay, if no any questions, I will continue. And a lot of tools for filtering of chemical reactions, a lot of tools like reaction classes, also filters like you have in Scopus by article, patents, conference papers, and other things. But what is very important, together with text filters that like you have in Web of Science and in Scopus, here you have chemical filters, and you can combine them. You can combine text filters and chemical filters. It was I want to tell you that this tool was developed for chemists and developed by chemists and for chemists and chemists. And it means that you can really combine it and make a very unique search that really need for you, not only search by text. Okay, let's go back to our substances, to our CETAN. And here also you can find also way of preparations of CETAN. You can find more than 200 way of preparation of these substances with details information about experimental procedure, and you can choose between them. And also we have a special tool for create synthesis plan. If you want to make create synthesis plan for any substance that you're finding in Reaxys, you just click to create synthesis plan, and then find the preparation and create synthesis plan. Let's click to create synthesis plan, and you have a lot of instruments for professionally developing of synthesis with prediction or without prediction, like based only on the published articles or on the predicted roads. Let's go to only to publish it. We are interested what doing other scientists in the world, and you can really work with every chemical reactions. You can view them. You can make planning. You can understand which solvents is used. Analyze the document. It's really professional tool for chemical synthesis and for work with chemical synthesis. Okay. What I was talking about properties. That in Reaxys you will find properties. You will find physical data, for example. In Reaxys, like melting points extracted from a lot of document, and you can see that sometimes numbers are a little bit different because scientists measure it. It's a little bit different. What it means? We are publishing. We are extracting it from the published articles and patents as it is. We are not change anything, but if you see that some numbers a little bit different from others, probably it could be interesting for you, and you can also look on the citation. Very often, everybody thinks that if a document is citated, the quality is higher. it's probably it's, truth, and you can use the numbers that from the document where a lot of citations. And also, as I was telling you, you can mark any document and export to PDF or to Excel file and work with it offline. And for example, make some drawing, prepare some figures based on it in Excel, and so on and so on. You don't need to make any manual work like copy paste. Everything will be extracted from 100 and 1,000 document at once and very fast. And for example, boiling points, refractive indexes, a lot of things are extracted, and you don't need to make any copy paste work, reading document. And for example, absorption. For absorption in on different temperatures, in different solvents, with different pressures, so on and so on. Everything is extracted, and if you find that some information if you need more from article, you can click on the doc full text and read it on the publisher's website. Also, what we have in React, for example, chromatographic data. We have chromatographic data where you can find various HPLC data could be found, various GC data could be found, TLC and other things. It's really huge of information about chromatography you will find in Reaxys about this substance. Also, spectral data is interesting. For example, NMR spectroscopy with numbers, with the solvents, everything is here, everything in one place, everything is extracted. Also, infrared spectroscopy also could be extracted. Also, UV spectroscopy, mass spectroscopy, UV spectroscopy. For example, for UV spectroscopy and for other spectroscopy data, you can find the comments like the data. And also, if you find supporting information, it means that somewhere in full text, even in open version, you will find specters. I will show you in this document how we can get it. It's published. We're going to publisher's website. We are lucky it's not Elsevier document. And somewhere it should be some information about spectral. And first time we redirected to this publisher. Yes, supplementary information. Go to supplementary information. And without buying anything, without payment to the publisher, we can get supplementary information, and we can get specters of the substances. Sometimes it's very helpful. It means that if you have supporting information, could be great to click to full text, and because you will find a lot of supporting information about spectroscopy and also about substances and something. Very often authors are publish this raw data. They not publish even full text that is available only by if it's not open access document. Very often spectral information are in full text, in open access. Do you think it's useful for you, Dr. Ibrahim?
Yes, it's very helpful.
Yes, do not hesitate to ask any questions. If you have, you can interrupt me and ask the questions.
Yeah, it's like a great job you did.
Okay, let's go back to our substance. What we also have in Reaxys, spectral data and other data. In other data, a lot of different things that like I was telling you, aseptic degradation, abiotic degradation by hydrolysis and photolysis, stability in soil, and all these things are extracted and available immediately. Also oxygen demand, and also where it's used in laboratory, where it's used in industry. Everything is extracted. And what very, very interesting, we have also all these filters in Reaxys. For example, filter use, oxygen demand, stability in soils. I will show you. It's not in quick search, it's in query builder. Query builder, it's advanced tools where we have a lot of different instruments. If you start for beginning, I recommend you start from quick search, but very, very fast you will need a lot of other tools like special chemical tools, like structure editor, like special forms. We have more than 600 of search forms here in Reaxys. For example, we can use tool and place here everything that we need. For example, we need to find some explosive material. It's not a problem, just place explosive here, and in use, click to substances, and we will find the substances that used as explosives, and find a lot of materials about this. You and learn the properties of these materials and so on and so on. Or you can place here farm with, for example, this farm with star, and we will find all the properties, all the substances or documents that used for pharmaceutical needs. A lot of substances that used for pharmaceutical needs you will find, and work with them and analyze them and have a lot of information about this. Also, you can place here for something from material size, I don't know, light alloys or something else. You will find everything in the if you're working for some scientific topics, place it here in search use and find it. Also very, very useful tool, I think. Substance properties and comments. And also you can place here some things, like example, like Alzheimer disease or something else. If you want to some application in pharma, you can place it here. Or liquid crystals, so I don't know, like something like catalysis material, everything about your scientific questions. And what is interesting, you can combine it. Spectral properties, like for example, UF spectroscopy, Raman spectroscopy, and other things. And you can combine it in groups, change the logical operator from N to not to near to next to a very interesting tool is near. For example, you can tell to Reaxys that you want to find 2 words in full text, but the distance between these 2 words will be 1, 2, 3, 6, or 5 words to find more relevant information. You can make really complex requests, but what I recommend you do not make too complex requests. Otherwise, you will not find anything. Just make step by step. Make some first step, and then over the history find the first request and coordinate it, combine it in groups, and use logical operator. It's really huge of information to find something. If you find 1 million results, it means the best good way to filter it by words, by specter, by use cases, by substances, by other things. And what you can also do, you can go to this history and save this request for future in your account, but you need to be to log in to your account. I recommend you to use the same registration data that you're using in Scopus and in Science Direct. We have one account for every our Elsevier instrument. You don't need to remember too much of passwords and logins. Use the same that you have in Scopus and Science Direct. You can save it in your account, give the name to the search, to someday go back and made another one request, another one search by this request, or you can even make the email alert. It will, if system will find some new article or some new document about the topic that interesting for you, it will send you email to just give the name to this alert, and it will and you even not going to Reaxys, but it working on you. It's scanning all the information that it have inside of the database and giving you new information about your scientific topic. It means it's really flexible tool, but you need to be registered. Okay, I can also, let's go back to our slides. I think it's good time because we have not a lot of time to the end. We have in Reaxys a lot of substances, a lot of properties, a lot of chemical reactions, a lot of bibliographic data, targets information and bioactivity information are available optionally for some customers, but not available of our AKB access. And what I can also give you, our Reaxys have a lot of professionally instruments, like that I will already shown you, but we also have structure editor. In structure editor, you can draw any substance that you need. For example, we can draw some substance with using the internal instrument of structure editor. And also, if you don't want to write it, to draw it, you can insert structure from name, or from cast number, or from smiles, or from Reaxys number. We can place, for example, some name of substance here, and we can do with this substance whatever we need. We can delete some carbons if needed. Let's delete these 2 carbons. We can we have special instrument like position variation bond, for example, like lasso. We can place this carbon in several positions, and now Reaxys will place this carbon here, and in other positions. We can do the same things here. that this carbon will be here, 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 and here. Let's click to query, transfer to query, and find. We have a lot of substances by this request. Like here. And what can we do? We can edit this request in Query Builder. And we can, for example, change it like we want. For example, we can place here some generic groups. If we want to find the similar substances, here you will find acyclic, cyclic groups, or but very often I'm using any group or hydrogen, or any group. Let's click to any group or hydrogen and place it here. It's also transfer it to query. And we will find everything that we need by this request. We will find more substances where in this position we have absolutely anything that we have in Reaxys. And also very interesting instrument is that I want to show you is smart group. We can place smart group here, R1, and then can explain to Reaxys what is R1. Like let's use as R1 our halogens. We need to connect to halogens R group attachment. And go to again to smart groups and explain that R1 is this one. And it will be place our halogens to this, and this position. Let transfer it to query. Click to substances. And find all the substances that we requested. But we can also click to, not only click on substances, we can click on reactions, we can click to targets, we can click to documents, so on and so on. If you need information about reactions, just click to reactions, and you will find a lot of chemical transformation where participate this substances that we are interested. What also we can do in structure editor, we can save your request to your hard drive in Smiles, for example, or in some other format. You can open it from a lot of different formats. If previously, for example, you was working in KimDraw, you can find it format here and import it from KimDraw, for example. Also, we have a very small version of KimDraw directly here in Reaxys. We can switch between these editors and switch to KimDraw. If you prefer working in KimDraw, it's not a problem. You can we can work in this version of KimDraw. We need a couple of minutes until it will be loaded. Yes, now we have this version of KimDraw, and we can work with them in KimDraw. And also we have in here in this version of KimDraw, we have templates, some aromatic templates like cyclic alkanes and other things that not exist in Marvin.js. It's also very functional over metallocenes, for example. a lot of things that could be interesting for you if you want to draw some something in KimDraw. What we also have here, we have here some tools like repeating unit. We can take some part of molecule and tell to Reaxys that this part of molecule we want to repeat from, for example, from 1 time to 10 times. With this substance, I'm afraid it will be not working. I will show you something else. How it works. Here we can place, for example, from 1 to 20. I just showed you to show the logic, and you will find that a lot of substances where this part is repeated several times. We can click to reaction and find reaction with these substances if needed. Also, what we can do with in Reaxys, we can click to any atom and tell that this carbon is charged. For example, is charged as a +1 to make radical from it. We can click to any bond, click to bond properties and tell that this is a reaction center, and it's this bond is make or change in the chemical reactions, or we can take some bonds like this and tell in bond properties that it is not the center, and this reaction will be not participating in chemical reactions. And everything like you want, like you was know in chemistry, you can draw chemical reactions. Here's place some reagents here. Place plus, place arrow, and it will be reagents. If we will draw it differently, we will place substance here and arrow here. It will be chemical reactions with where this substance is a product. If we wrote a chemical reaction like this, for example, Reaxys will recognize it as a solvent or as a conditions, or for example as the catalyst. If you want some additional information about chemical reactions, it's not a problem. We can a lot of things about filters for reactions, like data and conditions. You can place, for example, some reaction conditions here: time of reaction, pressure, pH value, catalysts, a lot of the products, reaction time, a lot of things. Okay, we have about 10 minutes until the end of our webinar. I think it's a good time for the questions. What do you think, Dr. Ibrahim? Do you have any questions?
Thanks, Dr. Mark. It was a great job you did. I have like a small question. Did Reaxys have an idea about expiry or what is the duration of a chemical material after preparation? Do you have an idea about this? For example, I wrote something in the chat box we can demonstrate.
Could you please repeat it? What's the question?
Like if we prepared some materials, do Reaxys have like if we can search on this material preparation time and the storage condition and how long the prepared material will be active after preparation?
If you find something new, if you publish it in the article, in maximum 2 weeks, it appear also in Reaxys. If you're publishing something in patent, we after 4 days after the publication in the Egyptian Patent Office, it will be also extracted in 5 days. It will be also in Reaxys. It means that it really fast time from the moment when you publish it anything and until the moment it will be available in Reaxys for others, and other people worldwide will be searching for it. Even it's not published in Scopus, it will be also indexed in Reaxys, depending from the magazine. We are indexing a lot of documents that also not indexed by Scopus. Do you think I'm answered, Dr. Ibrahim?
A little bit, but my question, like if we prepared some material or I'm searching for certain material, I will prepare it. And I need some idea about duration of the active ingredient after preparation. Like if I prepare it today and I'm planning to use it next month, for example, I'm searching for
Sergey, might be you can help me with the answer.
Yeah, well, as far as I understand your question, please correct me if I'm wrong, that you are looking for the information. So how much time do you need to make this certain molecules? So in case if you have a very specific compound, so you need to know the production time. Am I correct?
yeah, like the production time and how long it will be active till I use it, or is this a material, for example, like I have to use it just after preparation and like within 2 hours it will be like degraded or something. This
Yeah,
is what
it's kind of stability of your compound,
yeah,
right?
it's a stability and like an expiry date.
Alexei, do you have an answer on it? So there are actually 2 questions behind. The first one is the reaction time. So if you have all raw materials, how much time it needs to produce it? I mean, it can be hours, days, or even weeks potentially. And then how long these particles, this compound can be stable under the certain condition. So it's more maybe related to some physical and chemical properties.
Okay, very difficult questions. I will try to answer. Stability is really difficult to answer. if how long do you Dr. Ibrahim, do you asking the time for preparation is of time of experiment, how long you to get the material, to get reagents, to get catalysts, so on and so on, or time of time of reactions? It's a okay. I will answer to both of questions. If interesting.
No, I have the protocol for preparation of this material nanoparticle. It takes like 2 days, but my question is, can I store it for sometimes? I can't find the preparation protocol. If he can store it for a week or months. He didn't mention any kind of data about this. So my question is, if I prepared like this nanoparticle, for example, or any kind, let's like focus on this nanoparticle in a chat box. If we prepare it, do we have any idea about the stability of molecule for how long after preparation? This is my question. Like, if Reaxys can help us for the stability of molecules, or especially the prepared molecules. Like, we have some idea about the salts. There is no expiry date for inorganic salts. As like a general rule, we may have like some exceptions, but for organic salts or organic material, there's some debate about the preparation and stability of molecule, or the use of molecule. Like, we have certain time limits or time gap from preparation till use. If we can get like information about this, it will be helpful. Like, and
what
if we can get it, like, we can get it an upgrade for Reaxys. Like, great job.
What we have about stability at the moment, we have stability of soil, but I think it's totally not fit for you. But at least you can find the stability of some products of some similar products in soil. Probably it will help you a little bit. Also, we have photolysis. Abiotic degradation by photolysis. Probably it's also, this filter also will help you. You can place here pH value, exposure period, concentration, and other things. But if your substances is degraded by photolysis, also we have the same something. So abiotic degradation by hydrolysis. Also, you somehow you can estimate the stability of the substance also by degradation by hydrolysis. Also, but this filter that we have already in Reaxys, that was developed by our chemists, but also which filter I also recommend you. I recommend you combine the structure editor, write the products or write your chemical reaction here. Just let's place absolutely anything here in structure editor. And also combine this with keywords, with titles, with the filter titles, abstracts, and keywords, and words about stability. Yeah, stability. Oh, probably structure editor in combination with logic and with these keywords will somehow help you. Also, what also I can suggest you, if you can, I will send you my email in chat. Out Hitasan nanoparticle expiration after preparation. Hitasan nanoparticles. Let's try. As I remember Hitasan, probably Reaxys will find it. Yes, Hitasan. Transfer to query. Nanoparticles expiration. Okay, let's combine it with nanoparticles. We find 5 documents about this. I think Dr. Ibrahim, you need just to read all these 5 documents and you have all the information. Very probably there is some information about preparation. What do you think? Read about this
a protocol for preparation, but after preparation, how long the stability and it's like they talk about the effect in vivo. They not talking about the stability in vitro state, or if you like prepare the material today and leave it in a fridge for 1 week, for example, is it possible to stay in the same state or it would be degradable? Like this question is like I'm lacking the information about it.
Okay, what do you think about this document? Performance, it's about, as you see, Hitasan nanoparticles were, it's a part of hit from the full text. Here's the abstract. Well, probably this document will help you, I don't know. Let's go to full text. It's our document, it's our article, document from Elsevier. For me, it's available. Probably it also will be available for you. Probably something interesting exists in this document. I don't know. Need a little bit more time for analysis. I think it's not a problem. Analyze 5 documents.
Okay, I will guess like I will do for more and see this 5, and if I didn't find, I will try again.
I can give you my email.
Okay, that will be great. And thanks for this great presentation.
I'm asking you to write me a letter. Might be we can find something more about this together later. And what I'm also asking you to show information about Reaxys with your colleagues. That is fine. If you find it, there is a mistake in my email. Sorry, I will write it again. Yes, now it's correct. to share this information with your colleagues about Reaxys if you find it useful. And very probably might to be you can help us to organize the special webinar for your colleagues, for your department, or for your university or your institution that you are working. We will be also very pleased, and what do you think about this?
Yeah, it will be great opportunity. I will discuss with colleagues, and thanks for your great webinar and this great database.
Might be you can share with us the name of your university and your email if possible.
Yeah, I am from Cairo University, Faculty of Veterinary Medicine. I am a PhD student in infectious diseases. And I work in like an oil adjuvant vaccine. I was like searching for some boostering of immunity by adding the new immune boosting materials to the oil adjuvant vaccine. So this is my concern in my PhD.
Yeah, and Dr. Ibrahim, can you, if it's not a big deal, can you please drop your email here, because the question you ask about the stability of the substance is very valid.
Yeah,
we wish to check it a little bit further, and in a couple of days we'll come back to you with detailed answer on it. So it takes us a little bit more time to investigate. So, but we will be certainly happy to come back to you with the answer, and of course we'll send you this presentation just for your review if you need.
Yeah, thanks. And like I was mentioning before, it's a great presentation and a great database, and like Elsevier is like a great partner for each researcher. So thanks again for your time, and I think like I got 10 minutes more than your time. So
great.
Thanks, and great job and great presentation, and keep moving forward. Thanks.
Thank you for your participation, and I wish you to have a wonderful week. So let's keep in touch. Thank you.
Yeah,
thanks, Alexei. Okay.
Bye.
Bye.